Welcome back to another video. My name is Michael and I make weekly videos on sports science. In this week's video we're looking at how we can bin data using R and how it's useful for sports scientists. Binning data is beneficial because it helps us group a continuous variable into smaller groups or smaller bins. Binning data is valuable because it helps reduce the noise in our data and it can help minimize the effects of observational errors. Binning data is also great because it offers practitioners a more general understanding of the data and it helps with visualizing the data as well. In today's video, we're looking at three main ways that we can bin our data. The first is using the case-when function, the second is binning the data directly within ggplot, and the third is using the cut number or the cut interval functions. For today's analysis, we're using the soccer performance data that I have uploaded on Kaggle. I'm going to leave a link in the description below if you want to follow along. So to bin our data using the case-when function, the first thing that we need to do is summarize our data. So in this instance, we're going to be looking at the distance that the athletes ran, and we need to find the average and the standard deviation that they ran. So I've already ran this line of code and it gives us the mean and the standard deviation in the console below. From that, we're going to create four different bins. So anything above 2 standard deviations is going to be considered high. Anything between 1 to 2 standard deviations will be considered moderate. Anything between -1 to +1 standard deviation is going to be considered average. And anything below -1 standard deviation is going to be considered low. So those are going to be our four different bins. We're using the mutate function as well as the case-when function to create those four different bins. And we can run that line of code there and then even view our data frame. And we see we have our new column right here, distance_load. Now that we've binned our data, I want to create a couple of visualizations to showcase why binning data helps. So this first ggplot is just you looking at the distances that the athletes ran, and it returns 30 different bins. So although it shows more precise information, it's kind of hard to digest. So this next ggplot that we're looking at looks at our distance_load, where we're looking at our four bins of average, high, low, and moderate. I do want to point out that it is in alphabetical order at the bottom, so it goes average, high, low, then moderate, versus going low, average, moderate, or high, moderate, average, then low. So we're going to reorder the bars, that way it can make it a little bit easier to understand. To reorder the bars of our bar chart, we're going to use the factor and levels commands. So we're going to create a new data frame, call it WRD1. And then we're looking at the distance load, and we're calling on the factor command of distance_load. And then the levels we're going to concatenate. We're going low, average, moderate, then high. So when we run these lines of code here and then create our new ggplot looking at distance load of our WRD1, we see that they've been reordered to low, average, moderate, then high. The next method for binning our data is to use the bin function within ggplot to assign how many bins you want. So this first example, we're looking at our normal distance, and we have 30 bins. Now all we have to do within that geom layer is add the function bins equals, and then we can put in however many bins we want. So in this instance, we're going to do 8 bins. And the rest of the code stays the same. We're just adding the number of bins that we want, and we see that we've reduced it from 30 all the way down to 8. The last method for binning data in R is using the cut number or the cut interval functions. So when we're looking at cut number takes a quantitative vector and splits it into a given number of bins that are approximately equal. So the count within each bin is approximately equal, but the width of the bin or the range of the bin is not going to be equal. So we're going to take a look at cut number. We're just calling on the data frame and then the column that we want and then the number of bins that we want. So we can run that here and it's going to return in the console below. If we want to make it a little bit cleaner, we can use the table function here, and that's going to return it in a table, again still in the console. and we see that it's kind of between this 49 to 52 range, so it's approximately equal for each bin. Then we can also work it in directly into our data frame using the mutate function, and the syntax is the same, and it's just going to work it right into our data frame. So if we're working with ggplot, we can pull straight from our data frame using that mutate function. And like I mentioned, the cut number function uses approximately equal bins. The range of those bins is not equal, but the observations within each bin is equal. So if we were to run a ggplot using that data, it's going to show us that we have between 49 and 52 observations, and that doesn't really offer any substantial insights. So we're going to look at how we can use the cut interval function to give us better insights. So by using the cut underscore interval function, we can create bins of equal widths. So we're going to use the same syntax as above, except now we're using the cut underscore interval function. If we run that line of code, it returns everything in the console below. We can clean it up just a little bit by using that table function, where we see that we have different numbers of observations within each bin, but that the range of the bins are more standard. We can also work it in using our mutate function, so it's in our data frame, and that way we can create a ggplot off of that where we're pulling the data of our distance bin, and then we can see our different bins and the observations within each bin. If you found this video helpful, you can show your support by liking the video. Thanks.